Hi everybody, today we are going to solve previous year's questions from NEET of class 12 chapter 2 structure of atom from chemistry. Question 1. The value of Planck's constant is 6.63 into 10 power minus 34 joule second. The velocity of light is 3 into 10 power 8 meter per second. Which value is closest to the wavelength in nanometers of a quantum of light with frequency 8 into 10 power 15 per second? We have to find the frequency. So we have the formula as, we have to find the lambda wavelength, and we have the formula for frequency as c divided by lambda, which gives lambda is equal to c by nu. Lambda is equal to 3 into 10 power 8 divided by 8 into 10 power 15. We get 0.375 into 10 power minus 7 meter. If we convert this into nanometer, we get 4 into 10 power 1, which is 4 into 10 nanometer, which is option C. Question 2. The radioactive isotope 27CO60, 27 cobalt 60, which is used in the treatment of cancer, can be made by NP reaction. For this reaction, the target nucleus is, if you use 28 nickel 60 and bombard it with 1 neutron, then we get 27 cobalt 60 with the release of 1 extra proton. In these reactions, a neutron enters the nucleus and a proton leaves the nucleus simultaneously. So the correct option is C. Question 3. The frequency of radiation emitted when the electron falls from n is equal to 4 to n is equal to 1 in a hydrogen atom will be. They have given ionization energy of hydrogen as 2.18 into 10 power minus 18 joule per atom, and H is equal to 6.626 into 10 power minus 34 joule second. We know that energy is given by E is equal to h nu, from where nu is equal to E divided by h. Also, E is equal to minus 2.18 into 10 power minus 18 Z square by n square joule per atom. For hydrogen atom, atomic number Z is equal to 1. So, and N1 is equal to 4 and N2 is equal to 1. So if we substitute the values, we get delta E is equal to 20.4 into 10 power minus 19 joule per atom. We substitute this value in the first equation. Nu is equal to 20.4 into 10 power minus 19 divided by H. We get 3.08 into 10 power 15 per second. Option C. Question 4. The energy of second Bohr orbit of hydrogen atom is minus 328 kilojoule per mole. Hence, the energy of fourth Bohr orbit would be, energy in nth orbit is given by minus 1312 Z square by n square kilojoule per mole. For fourth orbit of hydrogen atom, Z is equal to 1 and n is equal to 4. If we substitute the value of n as 4, we get minus 1312 divided by 16, which is minus 82 kilojoule per mole. So it is option B. Question 5. The orientation of an atomic orbital is governed by principal quantum number. Your principal quantum number gives the energy of the orbital. Azimuthal quantum number, it gives the shape of the orbital. Spin quantum number gives the spin of the electron in an orbital, and magnetic quantum number gives the orientation of an atomic orbital. So correct option is D. As you can see here, magnetic quantum number gives information about the spatial orientation of the atomic orbitals with respect to standard set of coordinate axes. Question 6. Given the mass of electron is 9.11 into 10 power minus 31 kg, Planck constant is 6.626 into 10 power minus 34 joule second. The uncertainty involved in the measurement of velocity within a distance of 0.1 angstrom is. So according to Heisenberg's uncertainty principle, delta x into delta v is greater than or equal to h by 4 pi m. If we substitute the values of h pi as 3.4 and mass of electron 9.11 into 10 power minus 31, and here delta x is 0.1 angstrom, which means 0.1 into 10 power minus 10 meter. If we solve this, we get delta v as 5.79 into 10 power 6 meter per second. So sixth one is option B. Question 7. Consider the following sets of quantum numbers Which of the following sets of quantum numbers are not possible? So option 1, n equals 3, l equals 0, m is 0 and s is plus 1 by 2. It is possible. N equals 2, l equals 2. This is not possible because the values of l will be from 0 to n minus 1. And option 3, n is equal to 4, l is equal to 3, m is equal to minus 2 and s is equal to minus 1 by 2. It is also possible. Option 4, n is equal to 1, l is equal to 0, m is equal to minus 1. This itself is not possible because the values of m will be from minus l to plus l. And 5, n is equal to 3, l is equal to 2, m is equal to 3. This is also not possible because m should be lesser than l. As you can see here, for the first option, electron is in 3s orbital. Second is not possible. For the third option, electron in 4f orbital. Fourth is not possible. And fifth not possible. So here we can see for a given value of n, l is equal to 0 to n minus 1, m is equal to minus l to plus l, and s is equal to plus 1 by 2 or minus 1 by 2. So seventh is option B. The sets which are not possible are 2, 4 and 5. Question 8. If uncertainty in position and momentum are equal, then uncertainty in velocity is. According to Heisenberg uncertainty principle, delta x into delta p is greater than or equal to h by 4 pi. Since the uncertainty in momentum is equal to uncertainty in position of the particle, so we have delta x square is equal to h by 4 pi, and we get delta x is equal to 1 by 2 into root of h by pi. Equation 1. We can write this equation as delta x into delta v into m, because uncertainty in momentum is given as delta v into m. Then if we put the value of x here and solve, we get delta v as 1 by 2 pi into root of h by pi. Option C. Question 9. The measurement of the electron position is associated with an uncertainty in momentum, which is equal to 1 into 10 power minus 18 gram centimeter per second. The uncertainty in electron velocity is. So again, according to Heisenberg uncertainty principle, we get delta x into delta p is greater than or equal to h by 4 pi. From there, delta x is equal to h by 4 pi into delta p. And also they have given, we can write delta x into delta v is greater than or equal to h by 4 pi m. We substitute delta x as h by 4 pi into delta p into delta v is equal to h by 4 pi m. So from there we can calculate the value of delta v, and if you substitute the value of delta p as 1 into 10 power minus 8 and mass as 9 into 10 power minus 28, we get delta v is equal to 1 into 10 power 9 centimeter per second. Or we have another method. We can write the momentum as the product of mass and velocity. Delta p is equal to m into delta v. From there, delta v is equal to delta p by m. Again we get the same value, 1 into 10 power 9 centimeter per second. So 9th is option C. Question 10. Maximum number of electrons in a subshell of an atom is determined by the following. Here we have, for a given subshell L, maximum number of orbitals is equal to 2l plus 1. Since one orbital can accommodate 2 electrons, maximum number of electrons is equal to 2 into 2l plus 1, which gives 4l plus 2. And for a given shell n, maximum number of electrons is equal to 2n square. For a subshell L, maximum number of electrons is equal to 4l plus 2. So for 10, we can write 4l plus 2. Since they are asking it for a subshell, if they had asked it for a shell, we could have written 2n square. Question 11. Which of the following is not permissible arrangement of electrons in an atom? N is equal to 5, L is equal to 3, M is 0, S is plus 1 by 2 is permissible. N is equal to 3, L is equal to 2, M is equal to minus 3, S is equal to minus 1 by 2 is not permissible because the value of M should be from minus L to plus L. It can't be minus 3. So it is option B. Since you can see it here. For option A, it is an electron from 5f orbital. B is not possible. For option C, N is 3, L is 2, M is minus 2, S is minus 1 by 2. An electron from 3d orbital. For D, an electron from 4s orbital. Question 12. Which of the following ions has electronic configuration Ar3d6? So the electronic configurations of these atoms are given, and Ar3d6 is cobalt 3 plus. 12th, option D. 13. A 0.66 kg ball is moving with a speed of 100 meters per second. The associated wavelength will be. So according to de Broglie equation, lambda is equal to h by mv. H is 6.6 into 10 power minus 34 joule second. Mass is 0.66 kg. Velocity is 100 meters per second. So lambda is equal to 1 into 10 power minus 35 meter. 13, option C. 14. The total number of atomic orbitals in fourth energy level of an atom is. So here, total number of atomic orbitals in nth shell is equal to n square. In fourth shell, it is n is equal to 4, and number of atomic orbitals is equal to 4 square, which is 16. 14th, option B. 15th. The energies E1 and E2 of two radiations are 25 electron volt and 50 electron volt respectively. The relation between their wavelengths, that is lambda 1 and lambda 2, will be. So we have question 15. We have E1 is equal to 25 electron volt, E2 is equal to 50 electron volt. We know that E is equal to h nu, which is equal to hc by lambda. E1 is equal to hc divided by lambda 1. E2 is equal to hc divided by lambda 2. So if we find the ratio E1 by E2 is equal to hc divided by lambda 1 whole divided by hc divided by lambda 2, we get E1 by E2 is equal to lambda 2 by lambda 1. So if we substitute the values of E1 and E2, we get lambda 1 is equal to 2 lambda 2. 15th is option B. Question 16. If n is equal to 6, the correct sequence for filling of electrons will be. So if n is equal to 6, we have ns, n minus 2f, n minus 1d, and p. So here, according to Auer principle, in ground state of atoms, their orbitals are filled in order of their increasing energies, and the order of orbital energies is determined by the n plus L rule, where n is the shell number, energy level, and L is the azimuthal quantum number. If two orbitals have same value of n plus L, then orbital with lower value of n is filled first. For n is equal to 6, since we have 6s, 6p, 5d, and 4f in the options, so for 6s, L is equal to 0, n plus L is equal to 6 plus 0 is equal to 6. For 6p, L is equal to 1, and n plus L is 7. For 5d, L is equal to 2, n plus L is also 7. For 4f, L is equal to 3, and n plus L is again 7. But since we know if two orbitals have same value of n plus L, then orbital with lower value of n is filled first. Increasing order of energy will be 6s, then 4f, then 5d, then 6p. Orbital with least value of n plus L will have least energy. So the order of increasing energies will be option A, 6s, 4f, then 5d, and 6p. Question 17. According to Bohr theory, which of the following transitions in the hydrogen atom will give rise to the least energetic photon? So we have n is equal to 6 to n is equal to 1, n is equal to 5 to n is equal to 4, or n is equal to 6 to n is equal to 5, or n is equal to 5 to n is equal to 3. We know that delta E is directly proportional to 1 by n1 square minus 1 by n2 square, where n2 is greater than n1. Here n is equal to 6 to n is equal to 5 will give least energetic photon. or else we can check all the options. For the first option, n2 is equal to 6 and n1 is equal to 1. If we solve, we get 35 by 36. For option B, n2 5, n1 4. If we solve, we get 9 by 400. For option C, we get 11 by 900. And for option D, we get n2 is equal to 5 and n1 is equal to 3. So the least energy will be 11 by 900. Least energy photon. So from n2 is equal to 6 to n1 is equal to 5. Option C. 18. Maximum number of electrons in a subshell with L is equal to 3 and n is equal to 4 is. If n is 4 and L is 3, which means this is 4f orbital. Total number of electrons in a subshell is given by 2 into 2l plus 1. Then we have 14. Or else we can just remember that f orbital always contains 14 electrons, maximum electrons. Option A. 19. The correct set of 4 quantum numbers for the valence electron of rubidium atom Z is equal to 37 is. So, the electronic configuration for rubidium atom is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6 and 5s1. So the valence electron is 5s1, and for 5s we have n is equal to 5, L is equal to 0 for s orbitals, m is 0 since y of L is 0, s is plus 1 by 2 or minus 1 by 2. So for question 19 it is option C. 20. The orbital angular momentum of a p electron is given as. Orbital angular momentum is given by root of L into L plus 1 into h by 2 pi. For p electron, L is equal to 1. So therefore orbital angular momentum is root 2 into h by 2 pi. If we solve again, we get h by 2 root 2 pi. So 20 is option A. 21. What is the maximum number of electrons that can be associated with the following set of quantum numbers? N is equal to 3, L is equal to 1, M is equal to minus 1, which means it is 3p. And then for N is equal to 3, L is equal to 1 and M is equal to minus 1, the spin quantum number can have values plus 1 by 2 or minus 1 by 2. So therefore, since 3 quantum numbers are already given, that is 3p orbital, one orbital can accommodate only 2 electrons. So 21 is option B. 22. Based on equation E is equal to minus 2.178 into 10 power minus 18 z square by n square joule, certain conclusions are written. Which of them is not correct? Option A. Equation can be used to calculate change in energy when the electron changes orbit. Option B. For n is equal to 1, the electron has a more negative energy than it does for n is equal to 6, which means that the electron is more loosely bound in the smallest allowed orbit. Option C. The negative sign in equation simply means that the energy of electron bound to the nucleus is lower than it would be if the electrons were at the infinite distance from the nucleus. Or option D. Larger the value of n, the larger is the orbit radius. 22. So the incorrect option is B. Electron is more tightly bound in the smallest allowed orbit. 23. The value of Planck's constant is 6.63 into 10 power minus 34 joule second. The speed of light is 3 into 10 power 17 nanometer per second. Which value is closest to the wavelength in nanometer of a quantum of light with frequency of 6 into 10 power 15 per second? 23. We know that nu is equal to c by lambda and lambda is equal to c by nu. Speed of light is given in nanometers and the frequency also is given. If we solve, we get lambda as 50 nanometer. 23. Option A. 24. The outer electronic configuration of gallium atom atomic number with atomic number 64 is. It has the electronic configuration xenon 4f7 5d1 6s2. So 24 is option B. 25. According to law of photochemical equivalence, the energy absorbed in ergs per mole is given as, the value of H is given in ergs, 6.62 into 10 power minus 27 ergs. Speed of light is equal to 3 into 10 power 10 centimeter per second, and Na, Avogadro number, is equal to 6.02 into 10 power 23 per mole. And we know that energy for 1 mole is given as Hc into Na divided by lambda. We have the value of H, we have the value of C, we have the value of Na, then if we solve we get 1.196 into 10 power 8 divided by lambda ergs per mole. So 25 is option A. 26. What is the maximum number of orbitals that can be identified with the following quantum numbers? N is equal to 3, L is equal to 1, Ml is equal to 0. What is the maximum number of orbitals? Only one orbital will have the value of N is equal to 3, L is equal to 1 and M is equal to 0, because S can have the values plus 1 by 2 or minus 1 by 2, and it is 3p orbital. 26 is option A. 27. Calculate the energy in joule corresponding to the light of wavelength 45 nanometer. Planck's constant is given, speed of light is also given. We know that E is equal to h nu, and if we substitute the values we get 4.42 into 10 power minus 18 joules. 27, option D. 28. Be2 plus is isoelectronic with which of the following ions? B2 plus is, since you can see here, the species are H plus, which has 0 electrons, Li plus has 2 electrons, Na plus has 10 electrons, Mg2 plus has 10 electrons, and B2 plus has 2 electrons. So it is isoelectronic with Li plus. 28, option B. 29. The number of d electrons in Fe2 plus, whose Z is atomic number is 26, is not equal to the number of electrons in which of the following? So, option A is so number of d electrons in Fe2 plus is equal to 6. We can count here in the electronic configuration of this. Option A, Fe, iron, and number of d orbitals in iron is also 6. Option B is neon. Number of p electrons is equal to 6. You can count here. And in magnesium, number of s electrons is also 6. But in chlorine, number of p electrons is 11. So the number of electrons in Fe2 plus is not equal to p electrons in Cl. So option D is the right one. 30. The angular momentum of electron in d orbital is equal to 30. We know that angular momentum is given by root of L into L plus 1 into h. For d orbital L is equal to 2, so therefore angular momentum is root 2 into 12, 2 plus 1 into h, which is equal to root 6h. 30 is root 6h. Here they have just asked the angular momentum, not orbital, so we do not divide this by 2 pi. 31. Two electrons occupying the same orbital are distinguished by. So for same orbital, n is equal to same and L is equal to 0 to n minus 1, m is equal to minus L to plus L, but s, the spin quantum number, is minus 1 by 2 and or plus 1 by 2. So two electrons occupying the same orbital are distinguished by spin quantum number, spin of the electron, as you can see here. S is equal to plus 1 by 2 or minus 1 by 2. 31. 32. How many electrons can fit in the orbital for which n is equal to 3 and L is equal to 1? So for L is equal to 1, it is 3p subshell, and an orbital of 3p only 2 electrons can fit. Here they have just asked orbital, so in any orbital only 2 electrons can fit, so option A. 33. Which of the following pairs of d orbitals will have electron density along the axis? 33. Here dx square minus y square and dz square orbitals have electron density along the axis, while dxy, dyz and dxz orbitals have electron density in between the axis. So the correct option is C. 34. Which one is the wrong statement? The uncertainty principle is delta E into delta T is greater than or equal to h by 4 pi. It is correct because from Heisenberg uncertainty principle, delta x into delta p is greater than or equal to h by 4 pi, and if we substitute the value of delta p, we get m delta v, and delta v can be written as delta a into delta t, m into delta a can be written as f into delta t. So from there, delta x into f is E, so we get it. Option B, option A is correct. Option B, half filled and fully filled orbitals have greater stability due to greater symmetry, greater exchange energy, and more balanced arrangement. It is correct. Option C, the energy of 2s orbital is less than the energy of 2p orbital in case of hydrogen-like atoms. And option D, de Broglie's wavelength is given by lambda is equal to h by mv, m is mass of particle, v is velocity. So the only incorrect option is C, because in hydrogen-like species, energy depends on the value of n and does not depend on L. Energy of 2s is equal to energy of 2p. So therefore, option C is incorrect. 35. Which one is wrong statement? Which one is wrong statement? Option A, total orbital angular momentum of electron in s orbital is equal to 0. Option B, an orbital is designated by 3 quantum numbers while an electron in an atom is designated by 4 quantum numbers. It is correct. C, the electronic configuration of nitrogen atom is given as 1s2, 2s2, 2p, x1, 2p, y1, 2p, z1. It is wrong because according to Hund's rule of maximum multiplicity, the electrons first occupy orbitals parallelly. So this is the correct electronic configuration. So the wrong option is C. The value of m for dz square is 0. It is correct. 36. 4d, 5p, 5f and 6p orbitals are arranged in the order of decreasing energy. The correct option is orbital with highest value of n plus L will have highest energy. So for 4d orbital, 4 plus 2, 4 is n and d is 2, we get 6. For 5p, 5 plus 1, where 5 is n and 1 is L, which gives 6. For 5f orbital, we have 5 plus 3, where 3 is L, 5 is, n is 5, we get 8. 6p, 6 plus 1, 7. So 5f has greater energy than 6p, it has greater energy than 5p, and it has greater energy than 4d. So 36 is option B. 37. Which of the following series of transition in the spectrum of hydrogen atom falls in visible region? Here you can see the series: Lyman, it falls in ultraviolet; Balmer falls in visible light; Pasteur and Brackett infrared. So the correct option is option C, Balmer series. 38. The number of protons, neutrons and electrons in 71 Lu 175 deuterium respectively are. As you can see in deuterium, number of protons is equal to 71 Z, number of neutrons is equal to atomic mass minus atomic number, which gives 104, and number of electrons is equal to number of protons is equal to 71. 38 is option C. 39. The calculated spin only magnetic moment of Cr2 plus ion is. We know that magnetic moment is given by root of n into n plus 2 Bohr magneton, where mu is spin only magnetic moment, n is number of unpaired electrons. If we write the electronic configuration of Cr2 plus ion, we have Ar 4s0 3d4. So one number of unpaired electrons is 4. If we put the value of 4 in n, so we get root of 24, which is 4.9 Bohr magnetons. 39 is option D. That's it. Share, subscribe and like the video. Thank you.